Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox. Today we are going over rates, ratios, and unit rates, and we're just going to dive right into this, just trying to understand what even a ratio is. A ratio is just simply a comparison of two quantities, all right? We use ratios a lot in math, all right? We use them in coordination with proportion, which is just two ratios that are equivalent to each other, two equal ratios. But first of all, we just have to understand what a ratio is, and that's just a comparison of two numbers. And so you see ratios everywhere in your world, so many different places, and a lot of different varieties, all right? There's not just one kind of ratio, there's a bunch of different ratios, and you see them just about everywhere, all right? Here's one example right here on your screen that you have a carton of 24 eggs, and 3 of them have cracks in it, all right? So separately, you've got this concept of having 24 eggs, which is 24 eggs, and then you have this concept that some eggs have cracks in them. When you put them together, all right, they have kind of a connecting point that this carton has 24 eggs, that 3 of them have cracks. Now there's a relationship between those two numbers, and when you have two numbers that are kind of like at odds, not at odds, but they're different in concept, but then you bring them together through some kind of like relationship, now it becomes a ratio. We're saying that out of these 24 eggs, all right, 3 of them have cracks. All right, so now there's a ratio, and there's 3 different ways that we can write ratios. When you first begin to work with ratios, we teach you how to write them. You can write them with a colon separating them. You can write the ratios with the word to separating them. But if we want to work with them, we like to write them as fractions, just like that. So the first thing that you really kind of need to know how to do, and that your teachers will probably ask you to do, is to write ratios 3 different ways, which is what I've done right here, with a colon, with the word to, and then also with the fraction bar. And you're always going to want to pay attention to the order of the words. In this example right here, you've got a carton of 24 eggs, includes, you see that word includes right there. There's an implied word to, all right, inside that includes right there. Whatever comes before that, implied word to, or that word includes, goes first, and then whatever comes after that goes second. So it is kind of important to pay attention to the words, but there you go. This is a ratio, and it's written 3 different ways. All right, here's a different kind of ratio. All right, you've got right here a farmer, all right, who is preparing his field. All right, he's preparing a half an acre in 3 days. If you wanted to write that as a ratio, you could, do 1/2 of an acre to 3 days. All right, so we can represent that 1/2 as a decimal. You can leave it as a fraction as well. It's not going to bother. You're not going to bother anything by leaving it as a fraction. There's nothing wrong with that. All right, then you can do the same thing with the word to, and then you could write it in the form of a fraction. Now, we don't typically like fractions inside of a fraction right here, but we need to understand this is really not a fraction right now. It's a ratio, all right? But we like to write ratios as fractions because they work just like fractions, all right? If you know how to solve add, subtract, multiply, divide fractions, then you'll see ratios, whenever you're converting one ratio to the other, you can put it in the form of a fraction because they operate very similarly to a fraction. But here's another ratio, all right, which is just another comparison of two numbers, all right? The concept of miles, which is a measure of distance, and then the concept of hours, which is a measurement of time, they're kind of different concepts. But when you bring them together by describing Rick's road trip, that he can drive across the state at a rate of 375 miles per hour, or per 5 hours, sorry, in 5 hours, we're bringing these two concepts together, all right, and they have a relationship now tied to describing Rick's method of travel or mode or rate of travel, all right? When you bring them together, they become a ratio, all right? Now, this particular problem says rate. We're going to see what the definition of a rate here is just a second, but just for now, you can just simply understand that rate is the same thing as a ratio, or it's a kind of ratio. It's a special kind of ratio. All right, so again, these two numbers have a connection. If you wanted to write that as a ratio, you could do it three different ways, just like that, with the word to, with a colon, all right, or as a fraction, just like that, all right? So that's three different ways to write the ratio 375 miles to 5 hours, all right? And then finally, I've got this example of a girl who reads at a particular rate. All right, she reads 16 pages during a 30-minute period of school. All right, maybe you can pause this video and you can just try to write this three different ways yourself. All right, so if you've already done that, this is what it is, just like that. Not too difficult at all. Probably one of the easier things you'll be asked to do in 7th or 6th grade math is just to simply write numbers as a ratio. Again, the pages of a book are not directly related to a measurement of time, like this case right here, 30 minutes that she can read for 16 pages. These two concepts are different concepts, but when we bring them together in describing Bailey's rate of reading, now it becomes a ratio that she can read 16 pages in 30 minutes. Now there's a connection point between those two numbers, and that's why we call it a ratio. It's a comparison of two quantities, all right? That definition, a comparison of two quantities, there's another definition that I kind of like better, and it's a relationship of two quantities by division, all right? Ratios are just a connecting point of two different numbers, two different quantities, and it's a connecting point by division, all right? If we're talking about Bailey's rate of reading 16 pages every 30 minutes, then we could find by doing some division here how many pages can she read in 1 minute, all right? We could divide the 16 pages up by the 30 minutes, and we'd find out how much she can do in 1 minute, all right? So let's go ahead, and we're kind of moving ahead of ourselves, but let's go ahead and take that next step. All right, I told you already that a rate is just, could be understood as a ratio, simply a ratio. It's just a special type of ratio, all right? A rate is a measure. This is like the definite definition. If you went to Google, you'd find this definition. A measure, a quantity, or frequency, typically one measured against some other kind of quantity or measure. All right, so a rate is, a ratio that includes some kind of measure or frequency, and it's measured against another one. Now, I think it's a little bit more simply understood by this second definition right here. A rate is simply just a specific type of ratio that includes units of measure. All right, if we're comparing apples to oranges, like Sarah has 3 apples for every 2 oranges. All right, well, now that's a ratio because neither one of those numbers is a unit of measure. But if we say that Sarah can eat 3 apples in 1 minute, all right, now we're comparing those 3 apples to the 1 minute, and the 1 minute has a unit of measure, all right? It's a measure of time, minute is, and so now that special ratio is called a rate. So whenever you see the word rate, it's just really talking about a ratio that has some kind of unit of measure tied to it. All right, here's an example right here on the screen. A window washer cleaned 38 windows in 2 hours. All right, you've got 2 numbers here that are being compared, that there's a connecting point. Windows and hours aren't really related, but when you bring them together in describing what this window washer can do at a special rate, now there's a connection point. There's a relationship between 38 windows and 2 hours. They're connected by this window washer, all right? Who can do 38 windows in 2 hours. And we call this a rate because the 2 has a unit of measure attached to it, 2 hours, all right? So this is a special kind of ratio that's called a rate, all right? If I were writing that out, I could do it like this, all right? And I'm kind of getting a little bit ahead of myself because I'm going to teach you a special tool. This one's called a proportion map, where we write out the ratios that we have, and we give a verbal expression, then we give the given rate ratio, and then we have a variable ratio. I'm going to show you that on the next slide. But again, we can represent this window washer's rate as a fraction, 38 to 2, all right, which means you can do 38 windows in 2 hours. And then we can use that information to keep on going, to keep on working, to find out what he can do like in 1 hour. All right, that's called finding a unit rate. All right, finding a rate per one. Unit just means one, and so whenever you're given a given ratio just like this, you can do a little bit of work to find out and simplify that ratio to be able to find out what it is per one. All right, in this case right here, if a window washer could wash 38 windows in two hours, then we could do some division right here, and we could find out, well, that really can be simplified to understanding that he can do 19 windows in 1 hour. All right, let's go on and just talk a little bit about a unit rate, and then we can go ahead and try to start solving these. Unit rate, all right, so we said a rate is a special kind of a ratio. A rate has a unit of measures, all right, and then unit rates are special kinds of rates, all right, that are just a connection of the numbers, all right, connection or relationship between two numbers that have, at least one of them has a unit of measure, and the second number has to be the number one, all right? So a unit rate is some amount, some quantity per one, all right? So for instance, right here, if we were to see Sharon right here, Sharon can travel 660 miles in 12 hours. Well, that's not really useful in being able to try to compare that maybe to somebody else's rate of travel. We don't want to know what she can ultimately do in 12 hours. We really want to know how much can she travel in 1 hour. And so we can do a little bit of math, all right, a little bit of division here to find out what she can do in 1 hour. When we find that out, all right, when we do that division, what we found out is the unit rate. We found out what she can travel in 1 hour, all right? That's a unit rate. To be able to do that, I like to set up what I call a proportion map, which functionally looks like this, all right? I have line equals line equals line. This first ratio is just going to be a verbal, all right, a verbal expression. So this ratio is being given to us in miles per hour. So I'm just going to express that ratio with words. The second ratio is going to be a given ratio, which is the numbers that are being given to you inside the word problem, right? And then that third ratio right here is what I call a variable ratio, all right? We want to know how far can she travel in just 1 hour, which is a unit rate, all right? To do to fill in a proportion map, that's exactly how you do that, all right? Then all you have to do to solve this is just cross multiply and divide, all right? 1 times 660, multiply across.
All boys basketball players, 7th and 8th grade, come to the front.
You're going to multiply across from each other, and you'll divide by the third number. So 1 times 660 is 660 divided by 12 is 55, all right? And that would be our unit rate. That at this rate, Sharon can travel at the rate of 660 miles per 12 hours. Sharon can really travel 55 miles in 1 hour, all right? Why don't you try this one at home, all right? Go ahead and pause the video, read the question, and see if you can come up with it. And maybe try to use a proportion map. All right, this is how I'd use a proportion map. I'd first write it out, line equals line equals line, all right? First thing I'm gonna do is look for the two things that are being compared, and they're dollars and basketballs. So John spent $36 to buy 4 basketballs, and we wanna know what the price is per one, all right? So we see we've been given a ratio here, so we can have a given ratio of money to basketballs. Then the given ratio with numbers is 36 to 4. And we want to know what it is per one basketball. And then we can just cross multiply and divide. 1 times 36 is 36. Divided by 4 is 9. All right? It's got 9 basketballs. All right? Ratios, rates, and unit rates aren't particularly confusing. All right? It's really just by division. And by this point in 7th grade, you already know a lot of the division that you need to do. If you don't understand the question, and you know it's a ratio and it's asking for the number from another ratio, you can set up a proportion map. If you have any questions, you can comment in the comments down below. Hope you have a good day.